أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Data screening and imputation. Now, it's very important that before the data is collected, the data is properly screened, and if there are missing values, the imputation is performed. Data imputation. Now, there are four different methods that one can use for data imputation. Now, the first two methods, that is series mean imputation and linear interpolation imputation, they are performed in SPSS. Introduction. Before you can assess if one construct is influencing another, you need to make sure you are actually capturing the construct of interest via observed variables or indicators. Now, in this session, I will go over how to initially screen your data for data problems before you even start your analysis. Data screening. Now, the first step before analyzing your model is to examine your data to make sure that there are no errors, outliers, or respondent misconduct. You also need to assess if you have any missing data and how to sort out problems relative to your missing data. Once your data has been keyed in into the data or software programs like Excel, SAS, or SPSS, the first thing you need to do is you set up an ID column. Now, what I normally do is I usually do this on the first column of the data, and it is simply an increasing number from 1 up until the last row of the data. Now, this is done to make it easier to find a specific case, especially if you have sorted on the different columns. After forming an ID column, it is a good idea to initially examine if you have any respondent misconduct. Another thing which is important, if you are collecting data in paper form or you have filled in the questionnaire through paper, what you need to do is as you collect your hard questionnaire, number each of the questionnaire. Now, once you number each of those questionnaires, while keying in the data and then later finding out if there are any errors with the data, you can go back to the original questionnaire in the hard form. So once you have numbered in the hard questionnaire or the paper format of the questionnaire, you can go directly to that particular questionnaire and see if you have entered the data incorrectly or what's the correct value to be entered. Now, the quickest and easiest way to see if the respondent abandoned your questionnaire, what you need to do is just sort out the last few columns of the data in ascending order. Hence, you could see if the respondent dropped out of the survey and stopped answering the question, or rather questions. These incomplete rows are subject to deletion. If the respondent failed to answer the last few questions, you just need to determine if this amount of missing data is sufficiently acceptable to retain the respondent's other answers. For example, he only missed or didn't answer the last one or two questions. Then there is no point deleting the whole response. But what if he missed out on 40-50% of the questionnaire of the questionnaire? So what you need to do is you can actually delete that particular response. After making a determination if respondents who fail to complete the survey should be deleted, the next thing you need to assess is respondent misconduct. Let's say you have asked the survey on a Likert scale from 1 to 7. You want to assess if the respondent simply marked the same answer for every question. The likelihood that the respondent feels the exact same way for every question is small and is subject to deletion because of the respondent's misconduct. We do not normally have the same answer for each question. So there is bound to be a variation in the responses. Now, if the respondent answers all the question with a similar response, there is a chance or highly likely that this is a misconduct and he did not or she did not actually read the questions. Sometimes you will also hear a yay saying, where the respondent is not reading the questions and just marking the answers or the responses. An additional step you can take to assess if the respondent misconduct is taking place is to add attention check measures to your survey. Now, these questions are added simply to make sure the respondent is paying attention to the questions, and they may ask the respondent to specifically select a number on 1 to 7 scale. For example, you may add reverse questions to your questionnaire. So this will help you assess the respondent misconduct and keep a check on the respondent as well. To see if you have a problem with your dataset, examining the standard deviation of answers for each specific respondent is a very good way to assess if the respondent misconduct is present. Now, while SPSS is a great tool to analyzing the standard deviation, in SPSS this is quite a job. Now, in order to do this, what we will do is we will use Excel. So what we do is Excel is a bit quicker. So let's use Excel to identify if there is a certain amount of standard deviation. Now go to the last column that is blank and simply input the standard deviation function in Excel and highlight only the Likert scale items or statements and do not include your ID column. This will allow you to see the standard deviation of each row for each respondent. Now anything with the standard deviation that is less than 0.25 should be deleted because there is little or no variance among the responses across the survey. Now how do we do this? Let's first do this. Let's say here are my responses. So we go to the last column here and we simply add the function is equal to standard deviation dot p. Now we select all our Likert scale items or questions. Now this is done and just press enter. Now in order to extend it to all the responses, just select the first function and here just double click this plus sign and see this is extended to all your responses. Now are there any responses less than 0.25? Well, I see here. Let's sort it out. So we select this column, sort and filter, smallest to largest. Expand the selection, yes, and see we've got only one that is less than 0.25. This one is greater than 0.25. So this one may be deleted because there is hardly any variance. And you can see this yourself as well. Now moving on. Now saying that, it does not mean that if standard deviation is under 0.25, you need to automatically delete the record. As the researcher, you need to determine what is an acceptable level of agreement or actually disagreement within the question. And this can be a matter of how large or how small the survey is as well. So if it's a large survey or a small survey, the value of standard deviation might change. But this is a rule of thumb. Now there is no golden rule that you can apply to every situation. But if you have a standard deviation of respondent that is less than 0.25, then you need to go to strongly consider if the respondent answers are valid. And then obviously you move forward. Now screening for impermissible values in the data. Now there are times when the respondent simply key in a value wrong or list an invalid response to an inquiry. To test if an answer is outside an acceptable range, you need to go to SPSS file and check for minimum and maximum value. Now to do so, what you need to do is go to Analyze, Descriptive Statistics and Descriptives. Now how do we do this? How do we find if there are impermissible values? So we go to our SPSS file and let me import the data. So you open SPSS, open another file, click Open. Now where is your data? So my data is in Excel format. Here it is. Just open it. Just click OK. And here is your data. Now how do I find out if there are any values that shouldn't be here? So what I need to do is I need to go to Analyze, Descriptive Statistics and then Descriptives. Now here are the variables. Let's see, I'm interested in, let's say, these four. So I just put it in here, go to Options, select minimum and maximum, make sure they are selected and just click Continue, press OK. Now look here, 125, 125, 125, 125. Yes, this was the minimum value and this was bound to be the maximum value. So there are no issues with impermissible values. Moving on. How do I assess if I have missing data? So we have already addressed how to find a respondent's abandonment, but finding missing data that takes place in random manner can be more challenging. To initially see if we have got any missing data, let's use SPSS. So in SPSS, what we do is we go to Analyze, Descriptive Statistics and Frequencies. Let's go to our data and see if we've got any missing values. Analyze, Descriptive Statistics, Frequencies. Let's use these 5 variables or indicators. Go to Statistics. Let's say you are interested in minimum, maximum value. There are other values as well. You can get range, variance, standard deviation, skewness, kurtosis, mean and other stuff. Let's use mean as well and just press continue, press OK. And let's see if we've got any missing values. Let's say, are there any missing values here? No, there are no missing values in these variables. Just in case if you have missing values, what would you do? In order to sort out this problem, what we will do is we will address our missing data problem. So how do I address missing data? Now there are 2 prominent ways to handle missing data. One is a list or pairwise deletion and the other one is imputation. Now I do not encourage deletion because you throw away a lot of data by doing this. If a respondent misses one question, the whole survey is dropped from the analysis. So if you used listwise or pairwise deletion, what you are doing is you are throwing away very important data. So previous research has shown that you can remedy up to 20 to 30% of the missing data with an imputation technique and still have a good parameter estimate. So imputation is often a better option if you do not have an excessive amount of missing data. Imputation is where your software program will replace each missing value with a numeric guess. Now the most popular imputation method is replacing a missing value with a series mean of the indicator. This is usually done for its ease of use, but it has a drawback of reducing the variance of variables involved. Not to mention, this actually also fails to account for individual differences of specific respondent. A second way to impute data is to use a linear interpolation option. Now this method examines the last valid value before the missing data and then examines the next value after the missing data and imputes a value that is between those 2 values. Now the linear interpolation imputes based on the idea that your data is in line or is linear. So how do you do series imputation? To use a series imputation and linear interpolation imputation, and this can be easily accomplished in SPSS. To replace missing values in SPSS, you need to go to Transform and then Replace Missing Values. A pop-up window will appear where you will need to select which indicators have missing values and need to be imputed. When you select the indicators to impute, the default imputation is series mean, labeled as S-mean. SPSS will impute the series mean for these indicators and create a new variable with an underscore and 1 as the new variable name. Now for example, 81 will be renamed as 81 underscore 1. Now how do you do this in SPSS? Let's go to SPSS and let's say I've got some missing values here. Let's delete a few values here. So we go to Transform, Replace Missing Values, and let's add 81. You can add multiple variables as well. Now there is series mean as a method. Nothing is required, just press OK. And your values are replaced by series mean. So where is your new variable? Here is your new variable. And this is the series mean. See this one here, this one here, and this one here. Now, what's the other method? In order to use the linear interpolation method, let's have a look here. It is very similar method to impute using linear interpolation method. After selecting the Transform and Replace Missing Values option, you need to select each indicator for imputation. And then, as stated earlier, the default method is actually series mean, but there are options. So what you do is you select linear interpolation option and make sure that you hit that change button to change the method. Now, how do you do this in SPSS? Let's go to SPSS, and here, since we took mean, series mean, let's use linear interpolation method. Let's delete a few values from 82. What we need to do is we need to go to transform, replace missing values, and I'm interested in 82. This one can be removed. You can add other variables as well if you want, but in this case let's use 82. Now this is the new variable 82_1. I'm not interested in using series mean, rather I'm interested in using linear interpolation. So method is linear interpolation. So I click linear interpolation, but nothing happens. So you have to select or click change. Now it is changed. What you need to do is just click OK, and your creating function is lint. All well, let's have a look. Now look here. So your missing values are replaced. Now which one? 82. The second value was replaced. Look at this second value, 5. But here it was series mean. Here it's discrete value. So this is how you can use both these methods to replace your missing values. Now, in order to know more about missing values, this is a very good book to know more about missing values.